Hello everyone, my name is Karan Mashru and welcome to this video solutions of weekly coding contest. So let's look at the first question, that is reach Alice. So let's go through the question. Bob is in his university hostel where Alice calls and invites him to cafeteria. So Alice calls Bob to the cafeteria and Bob is currently in the hostel. The cafeteria is located at a distance d meters from Bob's hostel. Bob wants to reach Alice as quickly as possible. So the distance between the hostel of Bob and the cafeteria is d distance and Bob wants to reach quickly. Bob has two options to travel this distance. So there are two options to travel from hostel to cafeteria. First is walking and second is biking. So let's go through the description of walking. Bob can walk at a constant speed of x meters per second. So if Bob can walk at a constant speed of x meters per second, then the time taken by walking will be equal to how much? D is the total distance and x meters per second he can travel. So D by x will be the number of seconds for Bob to reach from hostel to cafeteria by walking. Second is biking. Bob can ride his bike at a constant speed of y meters per second. Okay. However, his friends often stops him to ask about his bike features, which wastes k seconds of his time. So, if the Bob goes biking from hostel to cafeteria, then the speed of the bike is constant, which is y meters per second. So, if the distance is d and the speed is y, then the time taken will be d by y. But when he goes by bike, his friend often stops him. So how many times the friend stops him, that is not mentioned. But overall, the total wastage of time is of k seconds. The Bob's friend might stop him multiple times, but the overall wastage of time is k seconds when he travels by bike. So the time taken to travel by bike is d by y according to cover d distance with y speed, and k is the number of seconds wasted. So this is the amount of time required to go through bike. Your task is to help Bob decide which mode of transportation will get him to Alice faster. So which mode of transportation, either walking or biking, will get him faster to Alice. If walking is faster, then return walk. If biking is faster, then return bike. If both the options take the same amount of time, then return walk, as Bob thinks walking is more beneficial for his health. So if walking is faster than biking or is equal to biking, both the time takes same, then we will return walk. Otherwise, if biking takes less time to reach from hostel to cafeteria, then we'll return bike. Okay. So if I just go through this simple example, if the distance is d 150 and x is 3, that is the walking speed, then the time taken through walking will be how much? 50 seconds. So Bob walks to Alice would be 150 by 3, that is 50 seconds. And the biking speed is 5 seconds. So 150 by 5, that is 30 seconds to go through the bike, and 12 seconds will be wasted by his friends. So that would be 42 seconds. So 150 by 5 plus 12 is 42 seconds. So 42 is less than 50. So biking is faster. So we output bike. Okay. Now we have calculated the time to go walking as well as biking. So if the time through walk is less than or equal to time through bike, then I will have to return walk. And if T2 is less than T1, then I will return bike. Okay. So that's all. Let's compile and run it. How much time this will take? This is a constant time operation. Okay. Let me submit it. Okay. So we have solved it successfully. Now let's move on to the next question. So now let's go through the second question, that is Bob's game. So there is a long description written here. So what I will do is, first I will explain you the question, what is given in the question, what we need to return, and then we'll go through the question line by line. So you will understand it better. Okay. So let's go through the question. So Bob's game. So what is given here is that Bob is a professor. Okay. And he likes to play games with the student. So he wants to play a game with the student. Now what is the game? So on the blackboard, what Bob does is he writes down n numbers. Okay. And now he asks all the students one by one to select one number. Okay. So asks students one by one to select one number from the board. Okay, select one number. Now, how is the number selected from the board? So there, let's say there are n numbers, there will be n students. Okay, there are n numbers on the blackboard, there are n students, and there is a string str which is of length n. Okay, now for all the values, for all I equals to 0 to n minus 1, okay, for all the students from 0 to n minus 1 index, Bob asks the ith student. Now what does the ith student do is, he looks at the value string of I. Okay, so this string which is of length n is a binary string. Okay, so here the values are only 0 and 1. Okay, so ith student, when asked to select a number from the n numbers on the blackboard, he looks at the ith character in the string. So there can be two possibilities, either this string is 0 or this string is 1. If the string is 0, then this ith student asks a girl to select a number from the blackboard. If the ith character in the string is 1, then the ith student asks a boy to select a number from the n numbers. What does girl do is, she always selects the minimum number from all the numbers on the blackboard, and the boy always selects the maximum number from the numbers on the blackboard. Okay, till now it is clear. Also, a number once selected cannot be selected again. Okay, so a number from blackboard, we'll see an example, so everything will be clear. Okay, number from blackboard once selected cannot be selected again. Okay, everything clear till here? So there are n numbers on the blackboard, there are n students, and the professor asks all the students one by one to select a number on the from the blackboard. So there is also binary string of length n. So how does the student pick a number? So let's say it's the ith student turn, then he or she looks at the character in the string at the ith position. If that character is 0, then that student asks a girl to pick the number from the blackboard. If the number is 1, then that student asks a boy to select a number from the blackboard. The girl always selects the minimum number and the boy always selects the maximum number from the blackboard, and number once selected cannot be selected again. In simple terms, if the ith character of the string is 0, then minimum number from the blackboard will be selected. If the ith character in the string is 1, then maximum number from the blackboard will be selected, and the same number cannot be selected again. So what I can do here is, so if we look at this example, so these are the n numbers on the blackboard, this is the string. If the character is 0, then a girl will choose the number and she will choose the minimum number. So the first number selected will be 3 out of all this. Now once number selected cannot be selected again, so this will be cancelled. Next is 1, so maximum number will be selected. Maximum from these 3 is 11. Okay, and now this cannot be selected further. Again it is 1, so maximum of 7 and 5 will be selected. So 7 will be selected and this cannot be selected further. Now it is 0, so minimum will be selected, as there is only one number. This is only the minimum. So this is the answer. The n numbers, order of n numbers selected by students, which we need to return. So how can I implement it? So what I can do is, I can sort the array. For example, the array is 3, 5, 7, 11. This is the sorted array. I will keep one pointer here and one pointer here. Whenever I get the ith character in the string as 0, I'll select the minimum number and increment this pointer. So let's say this is I and this is j. If the ith character from the string is 1, then I'll select the maximum number and decrement j. So for example, if the string is 0, 1, 1, 0, so ith character is 0, so select the minimum number and increment I. So now my I will be here. So this number now cannot be repeated again anytime. Okay, I always points to the minimum remaining number and j always points to the maximum remaining number. Now we have 1, so I'll select the number pointed by j, so I'll say 11 and I'll decrement j. Now again 1, so I'll select the number pointed by j, maximum, and decrement j. Now it is 0, so I'll select the minimum number pointed by I, so I'll select 5 and increment I. So I will come here but will come out of the loop as all the n turns are over, and I will return this as the answer. So first we'll sort and then we'll use 2 pointers, and depending upon 0 or 1, I'll select the minimum or maximum of the remaining elements, add it to my answer list and return the answer. Time complexity will be how much? N log n plus n. So this is to select the numbers based on the string character values, and this is to sort. So overall the time complexity would be big O of n log n. Okay, let's look at its implementation. So let me take the code from here. Okay, so first of all I have taken a vector answer which I need to return. I have sorted my given array. Then I have taken I equal to 0 and j equal to n minus 1. Now I am traversing through all the characters. If the character is 0, then minimum number will be selected, which is pointed by I. So I will say answer.pushback array of I and I plus plus. And if a string of k is not 0, means it is 1, so maximum number will be selected pointed by j, and I'll do j minus minus. And finally I'll return this answer list, okay, or vector. So let us submit it. Okay, so obviously it will pass because we have selected the correctly submitted one, but here again it has passed. Okay, so let's go through the third question, that is beautiful subarrays. You are given an array ARR consisting of n integers. Okay, a subarray is called beautiful if the sum of minimum and maximum elements in the subarray is divisible by the length of that subarray. Okay, so let's say the length of a particular subarray is, let's say, L, and the minimum element is M1 and maximum element of that subarray is M2. Okay, M1 is the minimum element of that subarray, M2 is the maximum element of that subarray. So if the sum of minimum and maximum elements in the subarray is divisible by the length of the subarray, means if M1 plus M2 is divisible by L, means M1 plus M2 modulo L is 0, then that subarray is called beautiful. So I need to count the number of beautiful subarrays in the array ARR. Okay, so let me just explain the question in a little more better way. So basically what it is saying is that, let's say I have an array which contains n elements. Okay, so how many subarrays would be there? Number of subarrays of an array with length n is how much? Number of subarrays is n into n plus 1 by 2, right? So out of these subarrays, how many subarrays are such that, so for example, let's say this is a subarray whose length is L. The minimum element of this subarray is somewhere here, let's say it's M1, and the maximum element of this subarray is M2, let's say it is here. So if M1 plus M2 is divisible by L, means M1 plus M2 modulo L is 0. If this is the case, then I say that this subarray is beautiful. So I need to tell number of subarrays which are beautiful. That is what I need to return. What will be the brute force method? So ideally for all the subarrays, you keep a track of minimum and maximum element, and every time you check whether M1 plus M2 is divisible by the length of the subarray. If so, then do answer plus plus, keep a answer variable, initialize it with 0. So this will take how much time? Brute force method will take how much time? Brute force method in which ideally you generate all the subarrays. For every subarray, take the minimum and maximum element, check whether it is divisible by the length of the subarray, and do answer plus plus if yes. So brute force method will take n square amount of time. Okay, but we need to do it more efficiently. Okay, let's go to the question again. So first of all, let us understand this example. So if n is 5, total there will be 15 subarrays. Of this, out of that, 8 subarrays are beautiful. So if I look at the first subarray, its sum of minimum and maximum element is 1 and length is 1. So 1 is divisible by 1. For second subarray, the sum of minimum and maximum element is 4 because minimum and maximum are same and length is 1. So 4 is divisible by 1. Here also 4 is divisible by 1. Here the sum of minimum and maximum element would be 6, which is divisible by 1. Again 4 is divisible by 1. Here the sum of the maximum and minimum element is 3. And it is the length is also 3, so 3 is divisible by 3. Here the sum of maximum and minimum element is 4. 3 is max, 1 is min, and length of subarray is 4, so 4 is divisible by 4. Here the sum of minimum and maximum element is 4. 2 plus 2 is 4 and length is 2. So 4 is divisible by 2. So all these subarrays are beautiful. So there are 8 subarrays which are beautiful. Okay. Now if I look at the constraints, n goes till 4 into 10 to the power 4. So if I do it in n square, it will give me time limit exceeded. So I need to think of something more efficient. Okay. Now I know a lot of you might have thought about segment trees or using stack to find the previous minimum element or next minimum element, previous greater element, next greater element, or using segment tree to find the minimum and maximum of a subarray and whatnot. But this is quite simple as compared to that. Okay, if you have good observation. Okay, so what you need to observe is that the value of the array elements are between 1 and 26. What does that mean? So that means that if the value of the array elements is between 1 and 26, so for any subarray, when you calculate the sum of minimum and maximum elements, that is m1 plus m2, so what can be the maximum value of m1 plus m2? Let's say in this subarray all the values are 26. Because the values cannot exceed 26. If all the values are 26, then minimum is 26, maximum is 26, so that is 52. And what is the minimum value of m1 plus m2? Let's say all the array elements are 1. So minimum, all these sub-array elements are 1. So minimum element is also 1, maximum element is also 1. So m1 plus m2 is 2. So if I want m1 plus m2 to be divisible by length of sub-array, so the maximum value of m1 plus m2 is 52. So no value greater than 52 can divide m1 plus m2. If I tell you that a value, the length of this subarray is greater than 52, so m1 plus m2 modulo L will be equal to m1 plus m2. It cannot be 0 because m1 plus m2 is less than L. It's like this, m1 plus m2 is 30 and the length of the subarray is, let's say, 58. So 30 modulo 58 will be 30, right? So value greater than 52 can never divide a value which is between 2 and 52. Right? Are you getting my point? If the length of the subarray is greater than 52, it cannot divide m1 plus m2 whose value is between 2 and 52. I need the length of the subarray to be between this, or not between this, but from 1 to 52. Because 1 can also divide, right? So the length of the subarray must be between 1 to 52 to divide m1 plus m2, depending upon the constraints. So basically, I do not need to check all the subarrays. I only need to check the subarrays whose length is between 1 and 52. That's all. So I do not need to check subarrays whose length is 53, 54, 55 and so on up till n. I only need to check the subarrays whose length is how much? Between 1 to 52. Now, what will be the number of subarrays whose length is 1? It would be n. Number of subarrays whose length is 2, n minus 1, and number of subarrays whose length is 51, n minus 51. So what is the sum of all these elements? So there are 52 terms from minus 0, minus 1 up to minus 51. So 52n minus 1 plus 2 plus 3 up till 51. So this is equal to 52n minus 51 into 52 divided by 2. So which is nothing but n minus 51 by 2 into 52. So number of steps are this much. So I can say time complexity is nothing but 52 into n minus 51 by 2 is constant, right? And n can go up to 10 to the power 4. So 52 is also a smaller value. If you want to keep it, you can keep it, or you can also say big of n. But this would be a more, this would give you a better time complexity, right? So this is big of n into 52 and n value is, I think, 4 into 10 to the power 4 into 52. So this can easily be solved using given time limits. Okay. So now if the starting of a subarray is index I, What can be its ending index if the maximum length is 52? It will be I plus 51, right? From I to I plus 51, this is a 52 length subarray. So if the starting index of a subarray is I, ending index must be I plus 51 or before that. It cannot be after that, right? So based on these concepts, let's look at the code. Okay, so what I have done is I have taken long answer is 0, and then for I equal to 0, I is less than n, I plus plus. So this is the starting point of the subarray. Okay, so the starting point of the subarray can be 0, or it can be 1, or it can be 2, and so on, right? It's something like this. See, let's say this is my subarray. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, let's say. So if this is my I, this is the starting point, my ending point could be I, or I plus 1, or I plus 2, or I plus 3, and so on. Then next my starting point will be 1. For that, ending point will be 1 or 2 or 3, and so on. So in this way, I'll keep changing the ending point, starting point, and for that starting point of the subarray, I will take different ending points. Okay, so for every subarray, I will maintain the minimum and maximum element value. So for I equals to 0, I is less than n, I plus plus, this is I am changing the starting point. I have taken minimum value as 27 and maximum value as -1. Why so? Because for every subarray, maximum value would be greater than -1 and minimum value would be less than 27. So as soon as I apply minimum is equal to minimum of current minimum comma array of j, it would be updated first time. Okay, and maximum equal to maximum of maximum and array of j. So this -1 comma array of j would be maximum. So it will again get updated. Okay, so I have initialized them with this. Now j is the ending point of the subarray. So ending point can be I, or I plus 1, or I plus 2, up to what? Up to I plus 51, or end of the array, whichever comes first. Okay, so j is less than minimum of in comma I plus 51. Actually, since here I do not have a equal to sign, so this must be equal to 52. Okay, and j plus plus. And if the for a subarray starting at I and ending at j, the minimum is stored in mi and maximum is stored in ma. So if the sum of the minimum plus maximum is divisible by length of this subarray, what is the length of this subarray starting at I and ending at j? It is j minus I plus 1. So if it is divisible, then that's a beautiful subarray. So I'll do answer plus plus. Okay, and then finally I'll return the answer. So let's submit it. Okay, so we have solved this problem successfully. We have passed all the test cases. Now let's move on to the last question. Okay, so now let's go through the fourth question, that is restaurant queries. So first of all, let me explain you the question, then we'll go through the question line by line, then we'll try run it on a test case, and then we'll move on to how we can solve it efficiently. Okay, so first of all, let me explain you the question. So in this question, what is given is that in a restaurant, there is a menu in which there are n items listed, and we have been given an array which denotes the prices of the n items. Now there are q queries which you need to run. And the queries can be of two types, 1 or 2. If the query is of type 1, then it will be of the form like this. Okay, 1x minus 1, and the query of type 2 will be of the form 2xy. So if the query is of type 1, so how do we know it is of type 1 or 2? So depending upon the first value, we will know it. Okay, so these queries are being given to us in a 2D array of size q cross 3. So there are q number of rows and 3 number of columns. Okay, so the first column denotes what? It denotes the type, whether it is first type or second type. Second has value x, and third value for first type of query has -1, and third column for second type of query has value y. Okay, if the query is of type 1, you add x to the prices of all the items in the menu. If the query is of type 1, you add x to the prices of all the items in the menu. If the query is of type 2, you change the prices of the items whose prices are equal to x to y. You change the prices of the items whose value are x to y. And after each query, you need to tell the sum of prices of all items on the menu, of all items on menu. Okay, and for after each query you need to tell the sum of prices of all the items on the menu. So there will be q values which you need to tell because there are q queries. So after each query you need to tell sum of prices of the items on menu. So you store these q values in an array or in a vector and then you return that vector. Okay, so that is what is asked in the question. Let's go through the question line by line. A restaurant has a menu with n items. Okay, each item has an initial price of prices of I. Okay, you will receive q queries to update the price of the items. There are q queries to update. If the query is of type 1 x minus 1, then add x to the prices of all the items. If the query is of type 1, add x to the prices of all the items. If the query is of type 2xy, means if it is of type 2, then set the price of all the items that currently have a price x to y. So for all the items whose price are currently x, change them to y. Okay. Return an array where the ith element contains the sum of the prices of all the items after processing the ith query. So after ith query, what is the sum of elements in the prices array? You need to return that. Okay. Let's dry run it. So here I have been given, I have a prices array which is 1, 3, 2, 3. Okay. Now the first query is 1, 2, minus 1. So add 2 to all the add 2 to all the prices. So it will become what? 3, 5, 4 and 5. And now the sum of these elements is 5 plus 5, 10 and 17. Now I'll move on to the next query. 2, 5, 3. It is of type 2. So change the prices of all the items which are price 5 to 3. So there are 2 items at present whose price are 5. Please remember, now this is the updated array on which we are looking at. This is not the array on which we are looking at. So 5 will be replaced by 3. So it will become 3, 3, 4, 3. So this sum of elements is 13. Now the third query is of type 1. Add 1 to all the elements. So add 1 to all the elements. So it will become 4, 4, 5, 4. And here the sum of all the elements is 12 plus 5 is 17. So after first query, the sum of the prices is 17. After second query, sum of the prices is 13. After third query, sum of the prices is 17. So I'll return an array containing 17, 13 and 17. Okay. Now, how will we solve this question? So the brute force method is for each query, if it is of type 1, add x to all the items, right? And then find the sum of the elements. And for type 2, again traverse the array. Wherever the item is x, change it to y and take the sum of the elements, right? So for each query in brute force method, in each query, traverse through the array, update the values of the array, update the values. So if it is query 1, add x to all of them. If it is query type 2, then change the values whose prices are x to y, and then take sum of all the elements. And then add that sum to the answer list. So for each query, so what will be the time complexity? For each query, you are traversing the array. So it will be big O of q into n, which will give you time limit exceed. So you need to think of something more efficient. Okay. Now, how to think about these kind of questions? So what you can do is, see, you need to traverse through all the queries, right? You cannot skip that. But how you are handling the queries, that you can make efficient. So you are traversing the queries, you cannot do anything of that. But you can think of handling each query in a better way. Okay. Now, how to handle the queries? See, after each query, what I want is, after each query, what I want is, I want the sum of the elements. I do not want the exact elements. So there is no need to maintain the exact list of elements after each query if you can somehow get the right sum of elements. So let's look at both the queries, how we can handle them efficiently. So query of type 1 and query of type 2. How can you handle the query of type 1 efficiently? So query of type 1 is of the format 1x minus 1, where you add the value of x to all the elements of the array. So let's say your sum was, let's say, s. Okay. So now your new sum will become how much? if you add x to all the elements, your sum will simply become s plus x into n. So this is how you can handle the first query. Quite easy, right? If the sum, let's say the sum of all the elements of the array was 10 and the number of elements are 3 and the query is 1, 2, minus 1. So add 2 to all the elements. If you add 2 to first element, second element and third element, then the sum of elements will become how much? It was 10 initially, plus 2 and plus 2. So now it will become 16. That is nothing but 10 plus 2 into 3, right? The second query is interesting. Here you need to update the all the values which are x to y. Okay. But now think about it. Before query 2, there were some queries of type 1. So now what happens is, okay, let's break it into two parts. How can you handle this query of type 2? So what you can do is you can keep an count of every element. Okay. So for example, if your array is 2, 5, 2, 1, 5. So the count of 1 is 1, count of 2 is 2, count of 5 is 2. Now the sum of the elements is how much? 5 and 5 is 10, 10 and this is 15. Okay. Now if I ask you to run a query 2 and 4, so it is of type 2. Change all the values that are 2 to 4. So if you change all the values which are 2 to 4, so you have maintained the count of 2. You can maintain it in a hash table. So you can directly get count of 2 like this, or in a map you can say MP of 2. So you know count of 2 is 2. So what will be your new sum value? Your new sum value will be sum minus count of 2 into 2. Because if there were 2 2's and if you replace it by 4, so because these 2 go away, the sum reduced because of that will be what? 4. This 2 will go and this 2 will go. So this much sum will be reduced, and how much sum will be added? Count of 2 into 4. Are you getting my point? Because now the array will become 4, 5, 4, 1, 5. So how much sum you reduced? 4. And how much sum you added? 8, because you removed 2 2's and added 2 4. So your sum was how much? It was 15. 15 minus 4 plus 8, which is nothing but 19. So the sum here will be 19. That is 5 and 5 10, 10 and 4 14, 14 and 4 18 and 1 19. Okay, so this is how we can handle query of type 2. We can keep a hash table. Now, one more thing which we need to take care of is, if there is a query of type 1 in which we will add x to all the values, right? So this hash table must also change. Are you getting my point? For example, initially the count of the elements were, let's say, 2 5 2 1 5. So count of 1 was 1, count of 2 was 2, count of 5 was 2. Now if I run a query of type 1 1 minus 1, it means add 1 to all the elements. So now now the array will become 3, 6, 3, 2 and 6. So count of 2 will be 1, count of 3 will be 2, count of 6 will be 2. And count of 1 will be 0, count of 2 will be 0 and count of 5 will be 0. Right? So if let's say query 1 comes which updates your array, and then query 2 comes. Now when query 2 comes after query 1, so let's say query of type 1 came, after that query of type 2 came. So now if you do not update your hash table, then the values will be this only, that count of 1 is 1, 2 is 2, 5 is 2. But actually the counts have been updated. These are the current counts. So if you do not have an updated hash table, how are you going to do this? Sum is equal to sum minus count of 2 into 2 and plus count of 2 into 4. Right? One more thing. After doing this, sum is equal to sum minus count of 2 into 2 plus count of 2 into 4. You need to update the count of 2 as 0 and count of 4 as 2. Right? Because they have changed, 2 have changed to 4. So how do you change the hash table after query 1? If you go through each element of the hash table, then again it will give you time limit exceeded. Then there is no efficiency, right? So how do you update it? So there are two things. How do you update the hash table after query 1 and how do you update the hash table after query 2? Okay, so update hash table. So after query of type 1 and after query of type 2. So after query of type 2, it is easy. You just make count of x as 0. So okay, this is not the exact how you will do it, but I will tell you the exact. Let me explain you a little bit to make you better understand. Let me write it like this right now. So you will say count of x will become 0, but before making count of x to 0, you need to increase the count of y by x, by the count of x. So you will say count of y is equals to count of y plus count of x. Let's say initially the count of y was 5 and the count of x was 2. So this x is converted to y. So now the count of y will become 7. So count of y equal to count of y plus x, and count of x is equals to 0. So this is a constant time operation. You can do it after query 2 because you are changing all the x values to all the y values. But how do you update after query 1? Because here you are adding a constant value x to all the elements. So the idea is you do not update. Okay, so you do not update the hash values. So if you do not update the hash values, then how do you keep track of the updated values here? So what you do is you keep a variable add in which is initialized by 0. And whenever a query of type 1 comes, you say add is equals to add plus x. So what does this add variable denote? It denotes that till now, for all the queries which are of type 1 which came, what is the total value x which you added to all the elements? Okay, so this add variable tells what is the total value added to all the elements of array through query of type 1. So there are, let's say, 5 operations of type 1 in which the first operation is 1 5 minus 1, second is 1 1 minus 1, third is 1 3 minus 1, fourth is 1 4 minus 1, and fifth is 1 1 minus 1. So how many values have you added to all the elements till now? You have added 5 plus 4 is 9 plus 3 is 12, 12 and 2 14 you have added till now. So when you come to query 2 and if you are looking for an element whose value is 32, then you should actually look for an element whose value is 32 minus 14, that is 18 in the original hash table. You should look at an element whose value is 18, because the element whose value is 18 till now would have in that element through query 1 I would have added plus 14 till now and converted it into 32. Are you getting my point? So in query 2, if you are trying to convert 32 to 50, let's say, then instead of 32 you will find 18, because let's say till now through query 1 you have added values of 14. So 18, which was originally 18, would have now become 32. But since we are not updating it, it is still 18. So if x is 32 in query 2, you look for 18 in the hash table. Okay, and you look for the count of 18 in the hash table and update it. Okay, another thing, when you are updating the value of y, so they are telling that convert 32 to 50. So 50 is the present value. But if you look at in this sense, that if this 50 was present from the starting of the array, then this 50 would have actually been 36, because this 36 after adding 14 through query of type 1 would have got converted to 50. So you do not make changes for 50, you make changes for 36. Why? Because for further queries your add variable, so add variable cannot be different for this and this, it needs to be constant for all of them. So instead of making changes to 50, you make changes to 36. So this 14, the gap of 14 will come through this add variable. assuming that you have added this much values to it through query of type 1. Okay, so here what I was telling is this is not the exact way which you update it. You update it like this. So count of y equal to count of y plus count of x. You do not do it like this. You say count of y minus add is equals to count of y minus add plus count of x minus add. Okay, and then you say count of x minus add is equals to 0. And before updating this count values, what you do is you say sum is equals to sum minus count of x minus add. This is the count, but how much the sum will decrease? It will decrease with respect to x, plus count of x minus add multiplied by y. So you will keep updating this sum variable like this, and then update the count values in the hash table as well. And for query of type 1, you update the add variable, you do not update the hash table. Let's dry run it on our example so you get it better. So our example was it was this one, right? So let me just copy paste these values. Okay, so I have taken these values. So if I look at my count array, so my count of 1 will be what? 1, count of 2 will be 1, and count of 3 will be 2, right? Now sum initially the sum of the array is how much? 3 plus 3 6, 6 plus 1 7, 7 plus 2 9. Okay, and what is my add variable initially? 0. Now the first type of query came, it says 2. So how much elements, how much value you have added to all the elements till now? That is 2. What will your sum change to? Sum will change to sum plus number of elements is 4, and you add 2 to each of them, so it will become 17. So after first query your answer is 17. Okay, now this is of type 2. So for type 2 you look at the count of 5, but you do not actually look at the count of 5. See, understand it in this way. After first query, this array would have been converted to what? 3, 5, 4, 5, because you add 2 to all the elements. Now you are looking for 5, but you have not updated the array. So actually you should look for what element? You should look for 5 minus add. Add is the total value added till now to each element through query 1. So add is 2. So you should actually look at value 3 in the array. And I can see it. The 3's got converted to 5, right? So now what is the count of 3? I know it is 2. So here I will say sum is equals to sum minus count of 3 is 2. So it is like this, count of x minus add into x plus count of x minus add into y. So 17 minus count of 3 is 2, value of x is how much? 5, plus count of 3 is 2, and it is 5 is getting converted to what? You are converting 5 to 3, so plus 3. So this is 17 minus 10 plus 6, which is nothing but 17 minus 4, 13. So your next element would be 13. Also you will say count of x minus y minus add is equals to count of y minus add plus count of x minus add. So y minus add is how much? Y is how much? Y is 3. So 3 minus 2 is equals to count of 3 minus 2 plus count of x minus add. X is 5. 5 minus 2 is 3. So count of 1 is equal to count of 1 plus count of 3. Now, did you got this? Why it came like this? Because see, the count of 5 decreased by 2 and count of 3 increased by 2, right? So count of 3 must increase by 2. But after adding the value 2, the value which is right now 3 in the original array, it is what? 1. That's why it got converted to 1, and the current value which is 5. Current value which is 5 in the original array, it is 3. So this got converted to 3. So count of 1 is how much? 1 is equal to 1 count of 1 is equal to 1 plus count of 3 is how much? 2. So this will become 3. So this will become 3, and then count of 3 you will make it to 0. So this you will make it to 0, right? Why? Because this was your array 3, 5, 4, 5. You converted 5 to 3, so it will become 3, 3, 4, 3. Now in the original array 4 was what? 2 and 3 were 1. So count of 1 would be 3. Yes, because here we have 3 threes, and count of 4, that is nothing but 2, will be 1. Okay. So we updated the hash table also respectively, and now the query of type 3. 1, 1, minus 1. So you add 1 to the add variable. So this will become 3. And you say sum is equal to sum plus x into n. So here your sum is how much? N value is 4, right? There are 4 elements in the array. So there are 4 elements in the array. In a current sum is how much after second query? Sum of the elements is 13, right? See, 13. Right? Where is the answer? So this is your answer, 17 and 13. So 13 plus 1 you add to all the 4 elements, so it will again become 17. So your answer will be 17, 13 and 17. So finally your answer will be 17, 13 and 17. Okay, I hope you have understood it. Let's go through its code, so you if there are any doubts, that are also cleared. Let me take it from here. So I have taken one vector long answer in which I will return the sum of prices of all the items after each query. I have taken an unordered map to keep the count of each element in my array. I have taken one long sum equals to 0, which will return me the sum of query items of the menu after each query. I have taken variable I and j. I have taken add equal to 0, which denotes total value added to all the elements through queries of type 1 till now. Then I have taken x, y and c. Okay, c will be used as a counter. So first of all, I will traverse through the array and add all the prices to this sum. So sum will have the initial sum of prices. And I will store the count of each price. So if map.find prices of I is map.end, basically it's checking whether that price value has occurred before, whether that value is already present in the map. For example, if a price of 5 came for the first time, then I will make that value equal to 1, and if that has occurred before, then I will do plus plus. Okay, now I will traverse through the queries. If queries of I0 is 1, I told you queries is a q cross 3 2D array. So zeroth column will denote the type. So either the type is 1, then I go in the if condition, and if the type is 2, then I go in the else condition. If the type is 1, I need to add x to all the n items. So x is at the first index in the ith query at the first column. So queries of I1, add is equal to add plus x, because I am adding x to all the elements of the array. And how much the sum will increase? Sum will be equal to sum plus n star x. Okay, sum is the sum of all the elements of the array, and add is how much value have been added to all the elements till now through query 1. Okay, so how much value is added to each element through query of type 1 till now. So that is how queries of type 1 is solved. Type 2, you take the value of x from the first column and value of y from the second column. Okay, now in map you find x minus add, because if x is currently 50, you are looking for value 50, and if let's say 20 has been added through query of type 1, then that value 50 was originally 30, right? So if it is present, first of all, if that value is not present, then you cannot do anything. For example, if I ask you in this array 1, 3, 2, 3, if I ask you to replace all the values which are 9 as 2, now there are no 9, so there is no change, right? So first of all, you check whether that x minus add is present in the map or not. So if mp.find x minus add is not mp.end, then only go further. So count of that element is map of x minus add. So how much sum will be changed? So sum is equal to sum minus count multiplied by x. All the x will be replaced by y. So plus count into y. Now I'll need to update the count of y minus add in my map hash table. But if that value is not present, so if map.find y minus add is map.end, if that value is not present before, then that value will become count. If there are if I want to convert all the 50s to 30s and the count of 50 is 10 and there are no 30s, so the count of 30s now will be 10, right? But if the count of 30 was initially 10, then now it will become 20. So if the value is not present in the map, then make that count as C, and if the value is present, then add C to it, increment it by C. And this is also very important. If y is not equal to x, then make MP of x minus add, okay? Because if y is equal to x, okay? Now let's say that you are asked to replace 10 by 10, okay? Let's say you are asked to replace 10 by 10. So you incremented the count of 10 by 10. So the count became how much now? 20, right? But you cannot make it equal to 0, right? So if the y is not equal to x, so if x was 50 and y was 30, then make count of 50 as 0. Otherwise, if y is equal to x, then basically you doubled the value of that year. So you just divide it by 2. So MP of x minus add divide equals to 2. Okay. So because if x was 10, y was 10. So basically both of them have, let's say, count 10. Now when you do plus C, you are making its count 20. But actually it will remain 10 only, because 10 gets converted to 10. So again divided by 2. Okay. And after every query, just push back the sum value. Okay. Let's submit it. Okay, so we have solved this question successfully. What will be the time complexity? So on an average, this unordered map adding or changing the values take constant time, and this for loop is of size n, and this for loop is of size q, and inside the for loop the work done is constant, so it will be big of n plus q. I hope you have understood the solution of all the questions. Thank you.